Chapter 20, Video 3, Theory, Quantitative Electrolysis. So quantitative means we are doing calculations to figure out how much is produced and what is being used up, etc. So the mass of substance deposited during electrolysis, the mass of substance produced at an electrode during electrolysis is directly proportional to the time over which a constant electric current passes and the strength of the electric current. So that means if both of these are high, the amount of materials, amount of substance that is produced at each electrode is also going to be high, right? So the equation for current and time equation to get charge in coulombs is equal Q equals IT, current in amperes, time in seconds, you get the charge. The mass of a substance produced at or removed from an electrode during electrolysis is proportional to the quantity of electricity in coulombs which passes through the electrolyte. Higher is the charge, higher would be the yield, or higher would be the amount of substance that is produced. The quantity of electricity is often expressed in terms of a unit called the Faraday, F. 1 Faraday is the quantity of electric charge carried by 1 mole of electrons or 1 mole of singly charged ions. So that is a very important definition that you must remember. 1 Faraday is equal to the charge of 1 mole of electrons or 1 mole of singly charged ions. Remember that. Its value is 96,500 coulombs per mole. 96,500 coulombs per mole. So now if you take the electrolysis of silver nitrate, what happens is 1 mole of silver ions will require 1 mole of electrons to produce 1 mole of silver. So that means it requires 96,500 coulombs of charge to do that conversion. 1 Faraday of electricity is required to deposit 1 mole of silver. During the electrolysis of copper 2 sulfate solution, copper is deposited at the cathode. Now here there are 2 moles of electrons being involved. As a result, we would require 96,500 coulombs into 2 to produce 1 mole of copper. So molten sodium chloride, chlorine is produced at the anode, 2Cl minus, then will become Cl2 plus 2 electrons, right? So there the equation shows that 2 moles of electrons are released when 1 mole of chlorine gas is formed from 2 moles of Cl minus ions. So again it requires 2 Faradays of electricity, again because 2 moles of electrons are required. During the electrolysis of an aqueous solution of sulfuric acid, 4 OH minus ions convert into oxygen and water. Then 4 moles of electrons are involved. So as a result, 4 into 96,500 coulombs. So you understand it depends on how many electrons are involved. Right? So now we have to go into the practical aspect of it, or the calculation part of this. If the F has been given, we can find out the mass of substance deposited at an electrode or the volume of gas produced at an electrode. Whatever it is, we can find out the number of moles. Then using the number of moles, we can figure out whether it is a mass or whether it is volume that is being produced. So if the F has been given, or the vice versa, if they have given the equations, then we can figure out how much Faradays are required to follow that equation to completion. Right. Then worked examples. Question number 1. Calculate the mass of lead deposited at the cathode during electrolysis when a current of 1.5 amperes flows through molten lead bromide for 20 minutes. So there is a current has been given and the time has been given. right? Then AR value of lead has been given, and the Faraday definition also has been given. We can figure out many things we use in the information that has been provided, right? First of all, we have to figure out how many electrons are required for the reaction to take place for 1 mole. So lead is being deposited, so lead is 2 plus, lead 2 plus in lead bromide, lead 2 plus gains 2 electrons to produce lead, right? Then to produce 1 mole of lead, we would require 96,500 into 193,000 coulombs per mole, because 2 moles of electrons are required for 1 mole of lead to form. Then we have to find out how much of energy has actually been given. Current is 1.5 amperes, time is 20 minutes, 20 into 60, because we have to take it in coulombs, in seconds. Then we will understand that 1800 coulombs of current has been given. So we have 1 mole. To produce 1 mole, we need 193,000, but we have only given 1800, right? So we have to find out mass by using the proportions. 1800 is what has been given. Then if 193,000 is what is required for 1 mole, you divide it by 193,000 and multiply it by 207. Why do we multiply by 207? Because that is the mass of molar mass of lead. We get how many moles would be produced, because we have 193,000 is for 1 complete mole, but we have given the charge for 1800. So you divide that by and multiply by 207. That will give you 1.93 grams of lead has been produced. I hope you understood that question. Then let's go to worked example 2 once again. Here we are dealing with volume. Once again, it's a number of moles that we need to figure out. Calculate the volume of oxygen produced at RTP when a concentrated aqueous solution of sulfuric acid is electrolyzed for 30 minutes using a current of 0.5 amperes. Again, the same thing, we have to write the half equations and find out how much of electrons are involved in here. So what happens is, oxygen is being produced. They are talking about oxygen. So 4OH minus dissociates into oxygen plus water while releasing 4 electrons. So that means because 4 electrons are required, the amount of charge is 4F. So that means for each mole of oxygen, 4 electrons are being released. So that means for each mole of oxygen that is being produced, 386,000 coulombs of coulombs per mole energy is required. Then we have to find out how much charge has gone through. Q equals IT. That would give you 900 coulombs. So 386,000 produces 1 mole. Then how much would be produced by 900? You divide 900 by 386,000 and multiply it by 24. Why? 386,000 is, this is actually O-level mathematics. I hope you can understand that. 386,000 corresponds to 1 mole, that is 24. Then what is 900? You multiply, divide 900 by 386,000 and multiply by 24. That will give you 0.056 grams or cubic decimeters. I hope you understood. Let's write down a note and then we will go to the questions. Quantitative electrolysis. The mass of substance that is produced as a result of electrolysis depends on two factors. Number one, the time over which a constant electric current passes. Number 2, strength of the current. Number 2 is the strength of the current. If both of these are higher, the amount of substance produced would be higher. Then write down the equation Q equals IT. Q is charge in coulomb C, current in amperes, I is current in amperes A. Draw this one, and time is in seconds. Leave a line and write. The quantity of electricity is measured in Faraday, and it is defined as the quantity of electric charge carried by 1 mole of electrons or 1 mole of singly charged ions. 1 mole of singly charged ions. Leave a line and write 1 Faraday, 1 F equals 96,500 coulombs per mole. 96,500 C mol minus 1, capital C, yeah. Then write example Ag plus E minus giving Ag 1 into 96,500 coulombs, because only 1 mole of electrons are involved. Number 2, Cu2 plus 2 electrons giving Cu 2 into 96,500 coulombs. So that means to produce 1 mole of Cu copper, you would require 2 into 96,500 coulombs of energy. Etc. I hope you understood the details. If you need, and then I think it would be best if you can write down the fourth example as well. The 4OH minus aqueous giving O2 plus 2H2O plus 4E minus to produce 1 mole of oxygen. Then another important factor, if it is to produce 1 mole of water here in this equation, then you would require only 2 into 96,500 more 96,500 coulombs of energy, right? So that is something that you must understand. Okay, then write down to produce 1 mole of oxygen, 4 into 96,500 coulombs of charge. Right, I hope you understood all the details. Do question number 5, 6 and 7.